So welcome to this video again. So in this video, we're going to talk about partial derivatives. So partial derivatives are derivatives that have two different variables. So it will be a derivative of this kind of a function that would look like this. This is something that would be considered a function with two variables. And therefore, to derive is a bit different from what we've done already. So, how do we do it? We're going to start by doing it with an example. So, this is our function. So, we have x to the third power plus 3 halves y squared minus 3xy minus 124. That's our function. So what we're going to do is we're going to start by deriving we have to derive 2 times to get the first derivative. So what we're going to do is we focus on one particular variable and we derive it from there. And everything else is considered a constant. So here's another example. So for x to the third power, here our focus is x, as you can see here. So for x to the third power, what we're going to do is we're going to derive it as if it was normal. It would be 3x squared. So this is what we've been doing all this time. Now we encounter ourselves with a moment where there's no x and there's only y. So as I said, all we're going to do here is we're going to treat everything else as constant. So y in this case is a constant. So imagine it's just a random number. It doesn't matter. So in this case, imagine it's a 1. 3 halves times 1 squared, it's just going to be a number, and therefore here we just put 0 when you derive it, because there's no x multiplying this number. Same here, same concept applies. Y is treated again as a constant. So we have minus 3y times x, and minus 3y is considered a constant. So what we have is minus 3x minus 3y x, and we derive x. And what we have is the 1 power, so we subtract 1. We got x0 times minus 3y. And x to the 0 power is 1. Therefore, our derivative is minus 3y. Okay, and then minus 124 is just simply as it has always been. So now we're going to do the same thing but with y. So fy equals, here there's no y, so it's just treated as a constant. So we're going to do 0. And here we do have y, so we're going to derive normally, so it's going to be 2 times 3 halves y. Then here we have an x and a y, so it's the same concept as before. The y is the variable that we're analyzing, and the rest is constant. Since this is constant and this is just a y on its own to the first power, we're going to do the same thing. It's going to be minus 3x. And then minus 124, same as above. Okay, so this is how we would derive. You focus on one variable, and the other variables are constant. So once you have this, now we want to find out the minimum, the maximum points, and the saddle points. So how do we do this? In order for this to happen, we need to have some first order conditions. So FOC stands for first order conditions. These are the following: f of x is equal to 0, and y is equal to 0. So these, with these first order conditions, we will find the critical points. So what we're going to do is we're going to do f of x is equal to 0, and f of y, and f for y is equal to 0 as well. So here, if we simplify, it's simply 3y minus 3x. And what we see here is that if we equal these, we get y equals x. So now we're going to solve here. So what we're going to do is we're going to get y equals x. So everything that's x, we're going to substitute for y. So we're going to get 3y squared minus 3y is equal to 0, and this is equal to y equals 0 and y equals 1. It's simple math. Okay, and now we're going to plug in these numbers into x to find out what the critical points with x are. So these are our critical points for y, and now we need to find those for x. So what we're simply going to do is, for when y is equal to x is equal to 0, and y is equal to x is equal to 1. So these right here are our critical points. Okay, so from here what we're going to do is we're going to try and see what this function is. So for that we're going to do a little parenthesis here, we're going to explain. So for that we're going to follow what's called a Hagian matrix. So Hagian matrix requires you to do the second derivative, which is the same process as here, just once again. And it's as follows: as fx of x times fx of y times fy minus fxy. So that's our Hagian matrix, and depending on the result we get from this, we're going to find ourselves with a maximum, a minimum, or a saddle point. So for this, what are we going to do? First of all, we're going to try and get fxx, fxy, and fyy. So fxx, we're going to do the same. We have we're going to derive for x, and here it's simply 6x. Since this is constant, this is 0, so it's just simply 6x. We derive from y. For x, y, y, we're going to get this, and the same constant as above. We have 3y minus 3x. Minus 3x is seen as a constant, so it's 0. So we get only 3, since this is 3y, if you can see. And lastly, for fxy, which fxy is equal to fyx, just as a note. For fxy, we just take fx and we substitute for y, which is going to be minus 3. So now that we have these, we have to analyze through the Hagian matrix. So how do we do this? Basically, when the Hagian matrix, okay. So when the Hagian is greater than 0, we can have two options. We have a minimum and a maximum. So minimum will be when fxx is greater than 0. So fxx, 0. And max would be when fxx is less than 0. So those are our two options. When Hagian is less than 0, in that case, we find ourselves with a saddle point. So let's see the case we have here. So we're going to test point 0, 0. So 0, 0. And what we're going to do is we're going to apply it to the Hagian matrix and see what we have. So for fx of x, if we plug in 0, what we have is 6x. So since x here is 0, we just get fx of x is equal to 0. Fy of y stays as 3. And fxy equals to minus 3. So now we introduce this to our Hagian matrix, so we get 0. So fx of x 0 times 3, fyy 3, minus fxy, which is equal to minus 3. And this 0 times equals 0. Therefore, we have that our Hagian matrix is minus 3. Therefore, since our Hagian matrix is negative, we find ourselves with a saddle point. Now, if we were to test with our other critical point, we're going to do it here. So if we were to test 1, 1, we'd have different results. So what we have here is fx of x is equal to 6, fyy is still 3, and fxy is equal to minus 3. Sorry, I need to precise, this is to the squared power. So, so this should be minus 9. Excuse me. And so basically, we redo this again, and we get that 6 times 3 minus 3 to the squared power and this is equal to 18 minus 9, which is equal to 9. Therefore, here we have a positive Hessian matrix. Therefore, it can be a minimum or a maximum point. And since fx of x is greater than 0 here, so this is 6, this means we have a minimum point. Therefore, I hope I was clear. I hope you could understand how partial derivatives and understanding the anatomy of these functions goes. And yeah, see you next class.